Hello everyone, this is Hemalata, Assistant Professor, Department of Agriculture Engineering, SNS College of Technology. We are seeing a lecture series in solar wind energy. In this, we are going to say about the latest trends in the solar technology. Uh, Today we are going to say about the five facial solar panels, floating solar farms or photovoltaics, and space-based solar batteries, AI and automation, roadway, etc. Since their inception in the 1960s, the solar technologies have undergone a lot of changes over the years. Researchers and developers in the solar energy industry are constantly searching for new ways to improve the efficiency of solar panels. Earlier, solar photovoltaics were considered the future of solar cells. But today, with the greater development made in solar PV technology trend, any recognized solar energy company is adopting the recent trends in solar energy. By the term solar panels, the first thing that appears to one's mind is the image of rooftop solar cells, and this is for a good reason. Until today, these traditional rooftop solar panels have dominated the solar industry on a large scale. But this year, we have some impressive solar panel technologies that promise a brighter future for any solar PV system. First, we are going to see about the bifacial solar panels. These are the solar panels which consisting of the two phases. That is, the represent a breakthrough um, in the solar panel design. Unlike the traditional panels that capture the sunlight from one side, bifacial panels can harvest energy from both the front and the rear side. Uh, these bifacial solar panels are photovoltaic modules that capture sunlight on both the front and rear sides, enabling them to generate electricity from direct sunlight as well as reflected light from the ground or surroundings. The purpose is to increase the overall energy yield of the solar installation by utilizing the additional light reflected from surface, thus improving the efficiency compared to the traditional monofacial panels. The front side consisting of the standard photovoltaic cells that capture direct sunlight. Rear side utilizes the reflector light from the ground or other surfaces to generate additional power. In case of albedo effect, that is the amount of sunlight reflected by the ground or other surface that contributes to the energy supplied by the rear side of the panels. The additional energy captured from the rear can significantly boost the total energy production. Next one, floating solar farms or PVC. Um, the solar panels can float. Photovoltaics, it is called as a photovoltaics, which refers to the photovoltaic solar PV system that float on the dams, reservoirs, and other water bodies. The silicon panels have become more efficient and cheaper day by day, and R&D teams in the solar energy industry are um, contributed a great work and discovered the floating solar farms. It can float on the water bodies. It can be any kind of water bodies which can float. Then solar float panels or floating solar panels mounted on a floating platforms on the structure of the body such as lakes, reservoirs and ponds to utilize the available water resources for solar energy generation, addressing land scarcity and improving the energy generation efficiency in some cases. The design consisting of it is a floating platform. Panels are mounted on a bayonet platform that keep them afloat on the water bodies. These platforms are typically made from materials like plastic or lightweight metals. The anchoring or to prevent a drift and maintain stability, often using ropes or chains connected to anchors on the plank or reservoir floor. Um, Panels capture sunlight just like traditional solar panels. The water surface underneath can help in cooling the panels, potentially improving their efficiency. The floating platforms are usually constructed from UV resistant, corrosion resistant material to withstand the exposure to the water and environmental mechanism. Then next one is based solar. We can utilize the space for harnessing the solar energy, which can be used for the it is basic concept is the capturing solar energy in space, utilizing the using satellites and transmitting it back to the earth. The objective is to harness the solar energy continuously without atmospheric or geographical limitation and provide a reliable and consistent energy resources. The solar collectors or the satellites are equipped with the solar panels, that is the photovoltaic cells, capture solar energy directly in space where sunlight is uninterrupted by the clouds or night. Energy transmission is collector solar energy is converted into high frequency microwave or laser beams and transmitted to a receiving station on the earth. Large lightweight solar panels or arrays are used to capture the solar energy and include the mechanism of deployment, orientation, and the stability of the orbit. Then solar batteries. In the large, from the traditional, they are using the solar batteries. Here they are. Now it includes the energy storage device designed to store excess electricity generated by the solar panels for use when solar generation is insufficient, such as night or during cloudy periods. The purpose is to enhance the reliability and flexibility of the solar power system, allowing for energy self-sufficiency and grid independence. Then it can types is flooded lead acid or sealed lead acid, and absorbent glass mat can be used. It is one of the proven technology, lower initial cost and widespread availability. And by AI and machine learning, they can harness the solar energy by utilizing the latest technology. We can also harvest in the solar energy. It refers to the um, it refers to the it had taken center stage in uh, artificial intelligence and a solar system can be used to harness the uh, s- um, harness the solar energy, and the solar industry is no exception. Here, to improve the efficiency and reliability and management of the solar energy system, to leverage AI for optimizing solar energy generation, enhancing system performance, and reducing cost. Solar roadways. Solar roadways are used in the developed countries for harnessing the solar energy. Here, the it is a road surface embedded with PV cells that generate electricity from sunlight while functioning as a conventional road surfaces. The objective is to harness the solar energy in public infrastructure, integrate renewable energy generation into road networks, and potentially offer additional functionalities such as lighting, heating, and traffic management. And some of the buildings also integrated with PV. At the rooftop they can install the PV panels, and for the whole buildings they can use the PV generated electricity to the house. These are the recent trends in the solar energy. Thank you.